Okay, so this one we said sine theta over 2 is 1/2. So now we're going to do what? We have got our variable stuck inside, okay? And we've got the sine. I want to make sure I copied this one right. Was this one copied right from the, did I copy it correctly?
Yes, ma'am.
Sine of theta over, okay. So now this is what we call the inviolable argument. We haven't done this one yet, so we're going to do it right now. This one is in a next section, I think. But what we're needing to do is say, where is the sine 1/2? Okay, where is the sine 1/2?
30.
Okay, the sine is 1/2 at 30s, right? But the sine positive will be there and there, right? So now we're talking about the 30 and the 30 up. So we're going to say theta over 2 needs to be, what? Theta over 2 needs to be 30. Or theta over 2 needs to be, what would that be? 150.
Yeah.
150. Okay. Now, what happens when I multiply by 2 to get my theta by itself? Theta becomes 60, and theta becomes 150 times 2, which is 300. Okay. So, Susie. All right, so now I've got a 60 and a 300 as my solutions for that one, okay? Whenever that happens, you have to make sure that you don't run outside of the unit circle, okay?
Did you leave like 20 markers in here?
I did, and I need them back, thank you. All right, here we have write, this is lesson 51, and this one is a really super fast one, which is good because we got about 5 minutes left. Write 2.4 as a power of 10 and then as a power of e. Okay, so 2.4 is 10 to the x is what they're looking for, and 2.4 is e to the x. What will we do to separate the x, which we're trying to find, when it's my exponent? We're going to take the log of both sides. Okay, now when I take this one, I'm going to take the log base 10 of both sides. If I take the log base 10 of this side, that's called the common log, and I take the log base 10 of this side, what happens on the right-hand side? What happens to log base 10 of 10 to the x power? The x runs around to the front, doesn't it? This becomes my coefficient. What happens to log base 10 of 10?
It goes to 1.
1. All right, so the right-hand side goes to x, and I get log base 10 of 2.4, which I can find out in my calculator. Okay, turn my calculator on. I go to my log button. Remember, your log key is your log base 10. So I take my log of 2.4, and I get 0.3802. I would take it out to 3 or 4 decimal places, and then I can check it. Is 2.4 equal to 10 to the 0.3802? Okay, so I'm going to say 10. I'm going to raise it to the 0.3802, and I do get 2.39999. Okay, so 2.4. If I carried this out further, I would get closer. Okay, now on this one, I want to separate my x again. Wade, what will I do when I'm separating my x this time? Well, I can't do that till I do what?
Put the log in.
And which log would I use on this one?
Or the ln.
The natural log. I'm going to use the natural log. I use the log base 10 here, my common log, because I had a base of 10. I'm going to use my natural log because I'm dealing in base e. So I'm going to take the natural log of 2.4 is equal to the natural log of e to the x. But natural log is log base e. So log base e of e is going to go to 1, and my exponent's going to run around to the front, so the right-hand side becomes x, and the left-hand side, I'm going to use my natural log button, is 2.4, and I get 0.8755. Okay, so now what am I going to do to check? I'm going to go back here and say, is e to the 0.8755 equal to 2.4? Okay, so I'm going to say, E, which is the second button on my natural log key, raised to the 0.8755, and I get 2.40000. Okay, so isn't that cool? So that one's a very, very simple one. All right. All right. So now we close.